I think that there's several problems. Fundamentally, the first starts with the fact that most traditional BI tools are based on technology that is now some 20 years old. Of course, the concept of OLAP, online analytical processing, was first coined by a gentleman called Ted Codd, who was the father of the relational database, and he actually came up with the term when he was doing some consulting work for Arbor, if you remember, a BI company called Arbor. And it was from that engagement that the concept of the hypercube was invented. And this was, I think, the first product. It was in 1983. And there's basically the idea at the time was, of course, that commodities like CPU and memory were very scarce commodities. So if you're designing a software tool, or in fact any software application, then it would be madness to take it to optimize it on the base of memory or CPU. You would, of course, do it on disks and writing to disks, and of course having to aggregate data in order to get some decent performance. So you would aggregate data, you would summarize it, you would filter it in order to be able to get a reasonable performance. And of course that's what current traditional BI technology is based on, an architecture that is predicated by aggregation, filtering and disk-based access. And therefore the inherent problems with these tools are a constraint, a technology constraint by traditional, very old architecture, which results, in effect, in a very complex set of technology to support a very old architecture. And so that's what they're suffering from. I think some are more equal than others. I think, again, the same argument with with traditional tools, as that they're very old architecture, not taking advantage of advancements in technology. Since the early 80s, we've had the incessant march of Moore's law and the doubling of processing power and memory access every 18 to 24 months. We're now in the era of 64-bit computing, massively parallel, multi-core, multi-threaded machines that, of course, if you built a product 20 years ago, you're not really optimizing. So I think there's two camps of BI tool: those that are predicated by old architecture that cannot take advantage of modern computing power, and those that can. And in-memory products that use and exploit 64-bit architectures and multi-threading, multi-core computing are the other side. I think there's a misconception regarding in-memory. There's a lot of hype and focus on in-memory as being the holy grail or the sex and sizzle in new BI tools, and in fact I would suggest that this is a red herring. People are being misdirected, because in effect what in-memory is allowing you to do is just do things quicker. So it's a bit like putting placing a modern fuel injection system on an old car. It's still an old car. It'll just go a bit faster because you don't have an air carburet anymore. You've got a fuel injection. So I think in-memory is useful only when you combine it with other aspects and other exploitations of new technologies. Because certainly you can do, processing is much faster in memory than if you have to go to disk. So it's a matter of what are you doing. Can you be smarter in what you do and then take advantage of in-memory, not do old things by using in-memory. An associative search is a data storage metaphor in order that you can get access and aggregate data on the fly without having to be constrained by pre-built cubes or dimensions. So the older technology is saying, well, actually you can only ask a question if it is being driven by one of these predetermined attributes of the data, i.e. a dimension. And the modern BI platforms are saying, well, why have a concept of dimensions at all? Why can't you access data by any attribute of the data at any time? And don't aggregate before you ask the question, aggregate when you ask the question, because who knows what and when you want to aggregate. Again, so this whole concept of moving away from a predetermined view of BI, somebody else's view of what questions you may want to ask of the data, to put the power to the people who know their data and therefore can ask the appropriate question at the right time. and the technology has got to be powerful enough to manipulate the data at the point they click, not at the point they design and build the application. I think the answer is yes to all the above. And the reason why is I think they'll be realistic. I think people have invested a lot of money in traditional BI, particularly the larger enterprise, is that they've invested a lot. They need to get some return on investment, or they're just unable to just throw things out. And we certainly wouldn't recommend a sort of rip and replace type strategy. And I think in certain circumstances, the heavier data warehousing and all the regulatory and IT complexity that comes with it may well be appropriate in some circumstances. But that's not the total picture. If you want to really sort of democratize the use of business intelligence and get a bigger community using it, then you have to use different tools that are more fit for that purpose. So I think a coexistence of traditional products and more modern products is realistic, one for economic reasons if nothing else, and two because they are solving different problems. And in addition to that, the modern products like QlikView can actually exploit the investment that's already been made, much more so than the traditional products themselves. So what I mean by that is if you have an existing data warehouse, an existing data management layer, then QlikView will sit on top of that and use all its powerful analytical and aggregation capabilities and visualization capabilities on top of data you already have. So in a sense, we're sort of adding value to an investment that has failed many companies. So we're actually perhaps turning it to a positive rather than seeing it as a negative.